Good morning, all of you. Can you hear me?
Yes, ma'am.
Yes. Okay. Right, one question. The following data were obtained. The following data were obtained during first order thermal decomposition of N2O5 gas constant volume at constant volume. Find out the rate constant. Find the rate constant. 2N2O5 gas gives 2N2O4 gas plus O2. This is the equation. And the data serial number, time, seconds, P total in atmosphere. Number one, time 0. That means in the beginning, initially 0.5 atmospheric pressure. 2. After 100 seconds. 0.512. This is the data here. This is P total, this is P initial only. Alright. We have to find the balanced material. That is already given. That is 2N2O5 gas is 2N2O4 gas plus O2. Initially, what is the pressure? Initially, at T is equal to 0. Initially, the pressure is 0.5. That time here 0 atmosphere, no product is formed. But after a time, means at T is equal to 100. At T is equal to 100. At T is equal to 100. So in this gap, what happened? Twice N2O5. Twice N2O5 is moving, going that side. At a time, 2 are going. So, what is remaining? 0.5 minus 2x. Here, in the previous case, x, we considered x, but here it is 2. So, twice x gone. And here, what is coming? 2x. And here 1x. So this is the case after t seconds. After a time t seconds. This is the case. And at this time P total is given. This time you take the sum total of all those things, which is equal to 0.51. This is the total. Now you see pressure increase. Total pressure increase. Previously it was 0.5. Here now products are also formed. Of course, it gets reaction come. So this plus this, that is given P total. So you add all these things. That is 0.5 minus 2x plus 2x plus x is equal to 0.51. Minus 2x plus 2x got cancelled. So 0.5 plus x is equal to 0.512. That means x is equal to 0.012. You can take x from there. Now, this you have to substitute this equation is after a time take the remaining, and this is the initial. This is the initial. So let's write the equation for the rate constant. Just need find the rate constant K. So I'm going to find the rate constant. For the rate constant, given first order, since it is given first order, I'll be writing the rate constant like this. K is equal to 2.303 upon G is 100 seconds. No. Log initially Pi and finally what? P. Finally P, that is Pi minus what is that? 2x. Pi minus 2x. So you have to create the equations for each and every situation. You have to create a new equation. Alright. So here K is equal to 2.303 upon 100 log, what is Pi? That is 0.5 divided by Pi minus 2, that is 0.5, 0.5 minus 2 into what is x here? X is 0.012. Now you can calculate, you can find out K. So 0.5 minus 0.02 minus 0.024. So 0.5 minus 0.024, that is 674. So here 2.303 upon 100 log 0.5 minus 0.40. This is the answer. The answer I am giving 4.9 into 10 to the power minus 4 second inches, which is equal to, you can take it as 500 divided by 476, like that. Then 500 means 3-digit number, so 2 points, that is the characteristic. 50 plus 0, that you have to take from the logarithm table. So using the logarithm table, you can find out nowadays if the board examination logarithm table is not provided, they give these values. In the question, they give directly the values of okay, which is equal to 4.9 into 10 minus 4 second. That is the answer. And the next topic and the last topic is pseudo first order reaction. Pseudo first order reaction. We have seen first order reaction. Pseudo first order. Pseudo means false. Really, it is not a first order reaction, but at certain circumstances, it becomes the reactions of first order. It may be second order, but due to some conditions, due to some circumstances, it is behaving as first order reaction. So we call it as pseudo first order reaction. Means it is not actually first order, but due to some circumstances, due to some conditions, it is behaving like first order reaction. Such reactions are called pseudo first order. Spelling PS pseudo first order. Pseudo first order reaction. Right. Those reactions which are not truly of first order, those reactions which are not truly of first order, but under certain conditions, become the reactions of first order. but under certain conditions become the reactions of first order. The reactions of first order are called pseudo first order reaction. Are called pseudo first order reaction. Example, hydrolysis of ester. Hydrolysis of ester. Ester hydrolysis. That is CH3, CO2, C2H5. This is high ethanoate. E high, this is E high. So ethanoate. On hydrolysis means water, excess amount of water. It will give what CH3COOH and C2H5 an acid and an alcohol. Hydrolysis of ester. Break that ester into acid and alcohol. So normally it is a second order reaction. Normally, experimentally, it is seen that order of a reaction can be obtained experimentally only, not by merely looking into this balanced chemical equation. Experimentally, it was found that it is a second order reaction. So rate is equal to rate constant into C3COOC2H5 C2H5 into this is 1 and H2O1. H2O1. And we are putting K dash. This is 1. This is 1. This is 1. And we are writing here K dash. So all the experimentally it is found that this is the order of the reaction. What is the order of the reaction? 1 plus 1, 2. Second order reaction. But if water is excess, then it will behave as a first order reaction. So here, rate is equal to rate becomes what these two things become constant. If water is excess, say there is no change in water. There is no change in water. So water concentration is taken as constant. A constant is a constant will give you another constant. That is K. CH3, CO2, C2H5. Where K is equal to K dash into H2O raised to 1. K is equal to, where K is equal to, where K is equal to K dash into H2O raised to 1. Now, what is the condition? Water is excess. Water is excess. For example, in this case, CH3, COO, C2H5 plus H2. CH3, COOH plus C2H5OH. Okay, initially at T is equal to 0. T is equal to 0. 0 point initially let it be 0.01 molar. At that time, that side it is 10 molar. 10 molar solution. Now, after a time T, now this has become 0 molar. That time, that one that is 9.9 molar. Now you see, compared to this 10, this 9.9, the difference constant, not much change. But here there is a change, 0.01 to this thing. So if it is excess, this change we take it as, we don't consider that change. Compared to this 0.01, this is compared to 0.05. Excess. If this is excess, then it still is not considered or that is taken as constant. That 10 molar is taken as constant. So we say this is an example for pseudo first order reaction. If you calculate the K value for this reaction using first order kinetic states, first order equation, you will be getting constant K value constant. So you can say that this follows first order reaction, and we call it as pseudo first order reaction. By doing one example, you can understand this thing. Right, one question. Hydrolysis of methyl acetate. Hydrolysis of methyl acetate. Hydrolysis of methyl acetate in aqueous solution has been studied. In aqueous solution has been studied. Plus H2O, H plus acid hydrolysis or base hydrolysis. CH3, COOH plus H2 plus CH3OH. By titrating, liberated acetic acid, by titrating liberated acetic acid against NaOH, against NaOH, against NaOH. Oh. Concentration of ester, concentration of ester at different times is given in the table. Is given in the table. Time conservation is in moles per liter. Moles per liter. Time 0. Time 0 at 90. Time in minutes. Time in minutes. Means initially 0.85. 0.85. After 30 minutes, 0.8002. After 60 minutes, 0.7538. Molar moles per liter. After 90 minutes, 0.7096. As time passes, the concentration of the reactants that is getting decreased. Concentration. This is initial. This is initial. That is R0. This is R0. That time this is R. Again this is R0. This is R. This is R0. This is R. Now, question is what? So that it follows pseudo first order reaction. Means this data obeys what? First order reaction. So let us put these values in first order reaction, calculate K. If K is coming constant, that means it is following first order reaction. Show that it follows pseudo first order reaction as the concentration of water remain constant. As the concentration of water remain constant. What is the concentration of water? 55.55 moles per liter. Moles per liter. 55 moles per liter. You have 55.55 moles per liter. What is the value of K? K is equal to K dash into H2O raised to 1. Okay, so we are going to substitute these values. We are trying with first order reaction because they have asked to check whether it is first order reaction, pseudo first order reaction. And they are telling to check whether it is pseudo first order reaction. So we are taking first order kinetics, first order reaction. And the K, you are finding K is equal to 2.303. 2.303 upon G. K, first we can take 30 minutes. Log R is 0.85 divided by and R 0.800. So you can calculate this and calculate the value, and that is 2.002 minus 3 minutes. Minus 3 minute equals minute inverse, second inverse. Those are the units for the rate constant for first order relation. Now again we are checking K, whether we'll check and see whether we will be getting the same value. K is equal to 2.303 upon now 60. No, again R0 is 0.85 upon R is 0. This value, that is 0.7538, and you will be getting the answer as 2.002 minus 3 minutes K value. See, which is same as that at the top. 2.004 is same as 2.002. Again you can check the third value. With the third value, that is K is equal to 2.03 upon 90. No, 0.85 upon 0.7096, and the calculated value is 2.002 10 to the power minus 3 milliliters. So in all cases you are getting K value 6. You are getting K value 6. That means this experiment or this reaction follows first order reaction. So this is a pseudo first order. Now during this reaction, it is acid catalyzed. You are putting acid, and you see here again some more acid is coming as the product. In the beginning the reaction is very slow, but as the reaction proceeds it becomes faster because one of the product formed is also an acid. So this is as that acid, the produced acid will also be acting as the catalyst. So we finished this chapter, and the next chapter is solid state. Solid. A substance is solid or not, that depends upon two things. That is intermolecular force of attraction and thermal energy. Thermal energy makes the particles move apart. Heat energy, when you heat substance, if you heat ice, it will be changing into water. The molecules will be moving from each other. They are moving far apart, far away from each other. Then the solid becomes a liquid. So if thermal energy increases, solid will change its state. So thermal energy should be less. And intermolecular force of attraction. Intermolecular force of attraction will keep the molecules together. So intermolecular attractive forces should be high and thermal energy should be less. So these are the two opposing factors. Thermal energy will make the solid into liquid, and intermolecular force of attraction will make liquid into solid or make the particles impact to form that solid. Solids are generally classified into two types, crystalline and amorphous. In crystalline substances, there are particular shade. They have got definite shade. But in the case of amorphous, no definite shade. Irregular shape. And for crystalline, it has got cleavage property, we say. You can cut with a knife and the cutting edges will have flat, smooth, flat surfaces. We say crystalline compounds, the crystalline solids will be having cleavage property. But amorphous substances, just like this chalk, if I break this chalk, this chalk, this chalk, this doesn't have plain smooth surface. Uneven surfaces. Okay, so in the case of amorphous substance, or we say amorphous substances do not have cleavage property. In crystalline substances, the particles are arranged in a regular fashion, that is, regular and periodically repeating patterns you can see. Regular and periodically repeating patterns for long distances you can see. But in the case of amorphous solids, this regular and periodically repeating patterns are seen only for short distances or not at all. In crystalline substances, there is what we can say definite heat of fusion, that is fixed and definite. But in the case of amorphous solids, no definite heat of fusion. Again, in crystalline substances, or they show anisotropy, while amorphous substances are isotropic in nature. What is meant by anisotropy and isotropy? In crystalline substances, the particles are arranged. Particles are arranged in a definite order. So if you measure a physical property in different directions, you will be getting different values. Because you will be meeting this is a crystalline substance. When the particles are arranged, one type of particle, next type of particle, particle, again, next type of particle, this type of particles, they are in a regular fashion, they are arranged in a regular fashion. If you measure a physical property means electrical conductivity or resistance, specific resistance. If you measure it this way, means you are getting only each type of particles, you will get one value. But if you measure it this way, you will be getting, you are seeing different particles, so you will be getting different value. So this property is called anisotropy. Anisotropy. But in the case of amorphous, there is no fixed position, fixed places for these particles. They are all mixed. They are all mixed. You measure in any side, in any direction, you will be getting the same value. That is called isotropic. But crystalline substances are anisotropic in nature. When you measure some physical properties along different directions, you will be getting different values. In the case of crystalline substances, that is called anisotropy. But in the case of amorphous substance, you get the same value when measured these physical properties in any direction. That is called isotropic. Crystalline substances are true solids, while amorphous substances are pseudo solids, means false solid. Thank you.